Hey guys, what's up? It's David Prates and welcome back to Neuraspike.com. And in this tutorial, I'm going to teach you how to build your own NFT search engine using Python and OpenCV. And then in the following tutorial that's like after this one, I'm going to show you how to integrate your current solution into a Flask web application. So without further ado, let's get started on understanding the idea behind image search engine. So before I go ahead and walk you through my solution that I've implemented for this project, let me first, give you a highlight about the inspiration for this project. So I remember when I heard about the NFT business back then in like 2021 and hearing about how people were able to like flip a single piece of digital art that kind of looked worthless to me, okay? And at that time, of course, and how people were making millions out of this digital painting, which is quite ridiculous, to be honest with you. And one afternoon, while scrolling through Instagram, I spotted, this painting that actually sold for a tremendous amount of money. And I'm talking about millions of dollars, okay? And since I was like moving on a fast pace at that moment, I couldn't, remember the same profile or avatar that I saw. However, the only thing I had at that time was a screenshot. However, I would have shown you right now, but unfortunately, I already like decluttered my gallery. And during that time, I searched through the OpenSea's website to see if I could actually search for the name of that image that I found earlier on Instagram. However, I wasn't able to find a feature that let me, simply just upload an image that looked alike and as a result get a query of images so that from there I can actually find the name of, what that token was. And since that feature wasn't actually implemented, even up to now, you can check the website, it's not even implemented. And I was thinking, okay, what if I actually build one, myself? So I decided to actually implement a simple solution to solve this problem that I faced, months ago. That's like almost a year right now. That's why I actually decided to work on this project by implementing the best solution possible based on the current data set that I have. And one of the issues that I had while implementing this project was like getting access to OpenSea's API keys, which are actually private at the moment. And I tried applying for it and I kind of waited for 3 days and I didn't get a response from them. So I just decided to, just manually download like 100 images of like 3 profile avatars. So it was like CryptoPunks, Alien Friends, and Bored Apes, which was definitely like an painful experience. Okay, so without further ado, let's actually understand what is an image search engine. So you can think of it as a process that takes one image as an input and retrieves collections of images that are actually similar to your queried item. So you could actually think of it in the same way as how Google search actually works, whereby you ask it a question and you're going to get multiple results based on your search. However, this is not a text-based search, so it's more of like an image search. So it's actually, the same procedure. However, just think of it as, just using images. So without further ado, let's get down into the implementation for this project. So before I actually walk you through the process of this project, let's first, visit our project directory. So over here, we have like our data set, which, contains all the images that I have. So of like, Alien Friends, Bored Apes, and CryptoPunks. So these are the images that we're actually going to be experimenting with for this tutorial. And next we have like our Neuraspike package, which houses like, 3 Python scripts. So our descriptor, which just helps us, extract, useful features from our images. Then we have like a searcher script, which helps us, in finding similar images to our query image. And our util script, which is like, some other helper functions. Over here, we have like our output folder. So once we extract images from our datasets folder, we're going to store those extracted useful features in a CSV file. So which is what I have over here. And here I have queries, which houses like, 3 images that we're going to use as an input to query similar alike images. And we have the script extract features, which is, extract features from our images. And a searcher, which, helps us retrieve similar like images. So let's actually get down into how this works. So inside of our extract features Python script, we started out by importing all the necessary libraries. And then we, set up, our argument parser, which lets us parse input via our command line. And that's what our application is going to use. Then we also have this function that we called from our Neuraspike package. It's called load images from folder, which just loads all the images from this dataset folder and stores it inside of this variable image path. So if we take a look at this folder, what it does is like, we first of all initialize a list, and we just like, using os.list directory, it returns all the images that are within this directory, like dataset. And then we just, build a path and populate this image list. And then, we just return that. And next over here, we like initialize a list to store the features and as well as the label. So the features are like, you could think of it as an embedding, something that represent the image. And then labels will be definitely like, alien friends, CryptoPunks, and also as well as Bored Apes. And over here in this for loop, we just iterated through the list of images. And over here, we just, read the image using OpenCV, then extract file name. This is like a function in our Neuraspike package that just, extracts the file name from the image. And then over here, we have like this function extract color histogram. And what this does is just extract the colors in the histogram that explains the distribution of colors within like, each pixels in all the images within our data set. So if we take a look at it, what happens over here is that we're going to pass in, so it receives as an input and a BGR image. So what we've done over here is that we converted the color channel from BGR to lab space. So that's what we're going to be working with in this tutorial. And then we just, calculated the histogram of the image, normalized the histogram, and then converted this into like a feature vector. And we just returned the histogram. And over here, we actually converted it into a list because it's going to return a NumPy array. And we just, populated our features list with the histogram, and as well as also our label list with the name of the file. So once we've actually, gone through each and every single image to extract those features from them using, our histogram while working with the lab space. So what we've done over here is that we just iterated through our labels and features. And on this line 48, what we've done is that we just went through our feature vector and then just added like a comma between each number. And then while writing the file, so we already, opened, so we already, initialized this writer, CSV writer file. So once we write into a file, how we're going to store the result. So first we have like the image ID, which is the file name, and then followed by the feature vector, which was extracted from that image. And then once we're done, we just, close the file that we just opened. So if we actually run this command, I'm just going to, copy this and paste it on the terminal and click enter. So once that's done, it actually, creates a new file and output, so features. So if we take a look at it, so you can see first we have like Bored Ape and then, the feature vector that was extracted from that image. So you can see the numbers over there. So once that's done, then the next thing we actually need to look into is our search.python script. And what happens over here is that we start off, by importing all the necessary libraries, so Neuraspike, ArcParser, CV2, and OS. And then, we set up our argument parser. And what happens over here is that, so in order for our NFT search engine to work, we need to provide a query image. So what's that? It's going to receive this from the command line. So once it receives and loads an image, then stores it in this variable image. What's going to happen is that we need to extract the feature vector for that input image. So once we actually perform a search by calling this perform image search, what we're going to pass in is the feature vector of our query image, which is like an input. And then we're also going to pass in this features.csv file that we've extracted. So what's going to happen is that we're actually going to compare the distance between our query image with all the whole features within the CSV file, and the one with the closest distance, so 0 when 0 is actually the closest, and any number larger than 0 is actually further away. Not, it means like it's more or less and less similar to our query image. And then we're going to return like the top 10 image that are actually similar to our query image. So if we take a look into this function perform image search, what happens is that it receives like a query feature and then the file path, which is the file path to features.csv file. So here we just initialize like a dictionary where we're going to store the results. And what happens over here, we just loop through each and every single row within features.csv file. And then what happens over here is that we just, extract the class label and the features from each of the rows. So the first element in that list is our file name. So we're just going to store that over there. And then everything else, so from 1 all the way to the end, is basically, our feature. And then we're going to use the Euclidean distance to calculate the distance between our query image with that specific feature. So for example, this first row. And what's going to happen is that we're going to sort our Python dictionary based on the distance in form like an ascending order. And then later on, we're going to, use, Python indexing to just limit the result that we're going to return and display to the user. So after we have, the results actually, returned from this function perform image search, what's going to happen is that we're going to, show the query image to our screen. And then what's going to happen is that we're just going to iterate through the results. So first we have like our image ID and the score. And over here, we're just going to build a file path. So arg dataset is basically the path to this dataset. And then we have like the image ID, which is like, the file name. And then we're going to load that image and then, keep displaying the results to our screen. So let's actually have a look at the first one. So we're actually going to experiment with this query image, which is, bored apes. So this is my input, my query image. And then I'm going to, pass this, copy this, and just pass it over here on the command line and paste it. Click enter. And you can see like my query image and the result that I'm getting. So I've got this similar image. I've got this one, this one, this one, this one, and you can see the result. So if I pass in, the second one, which is actually a CryptoPunk, so it's actually this image, that's how it looks like. I'm going to pass it into the command line. So you can see the query image on my left and the results on my right. So I'm going to keep pressing enter. And finally, we can actually test the final one, which is like alien friends. And I'm just going to copy this and paste it on the command line. So you can see on the left, I have my query image, and on the right, I have like, the results. And that's it for this tutorial. So in the next tutorial, I'm going to show you how to take our current, boilerplate code and then, build a Flask web application so that we can allow the user, upload an image. Then as a result, we're going to return similar like images to the user. So that's it for this tutorial. I hope you did enjoy it. And if you like this video up until now, be sure to hit the like button. Don't forget to subscribe and also share this video with your friends. And until then, see you in the next tutorial.